everybody. Like Shuhan was saying, my name is Stephen Lee. I am the Business Development Manager at Agilant Technologies System Products Division. So today I want to spend a few minutes talking about the DC Power Analyzer. So that's this box over here. And I want to explain, give you a general overview of the product, different functionalities, different features, and maybe talk a little bit about your specific test requirements and how this can help. So as you can see, this is our DC Power Analyzer. And in general, this is a little overview of what this Power Analyzer can do. So first and foremost, it's a 1 to 4 channel advanced power supply. So on the box, you can see 1, 2, 3, 4. So it's a 4-channel power supply. And actually, if you look inside the box, you can see channel 1, channel 2 is up here, channel 3, channel 4 is down there at the bottom. So in addition to being a power supply, it's also a digital voltmeter and ammeter. So these values that you see here, voltage, current, these are the readouts from the voltmeter and ammeter as well. In addition to the metering capability, you have an arbitrary waveform generator, oscilloscope, and data logger. So it's about 4 or 5 different features packed into one box. So you have all those features packed into one box. And the value for this box is that you're allowed to get insight into the device power consumption in a matter of minutes and not hours. So you don't have to integrate together a separate digital multimeter, data logger, oscilloscope. Everything is integrated for you, and it's ready to go in one box solution. So I like to look at the different functionalities as a sourcing function and measurement function. So there are two groups of functionalities, and within each group there are three different distinct features. So in the sourcing function, it's a basic DC bias. So you can set over here. You can set 1 volt, 2 volt, 3 volts, 5 volts. So that's basic DC bias. You can also set an arbitrary waveform function. So you can set sine wave, square wave, triangular wave. Also, you can actually create your own waveform. So if you have a waveform that's very different, you can create every point on the waveform and output it into these outputs. And lastly, you have a sequencing function. So for example, if I want channel 1 to come on 2 seconds before channel 2, channel 3 to come on 5 seconds after channel 2, I can program the sequence of the turn on and turn off time, the sequence in exactly the way I want it to do. So after I go over this presentation, I'll go in the front and go over some of those functions that I talked about. So that's the sourcing function, is these different features. So on the measurement side, there are also 3 distinct features as well. So you have your basic DC measurements, so DC voltage, DC current, displayed on the front panel. Also, there's an oscilloscope-like feature where you can see, for example, if you have a sine wave, you can visually see the sine wave on the front panel as it's in real time as it's coming out of the output. So after the presentation, I'll set a sine wave and I'll let us kind of see the sine wave coming on this oscilloscope feature. And we also have a data logger function. So the data logger allows you to log the data for seconds, for minutes, for hours, even for days. So you can log the large data for a long amount of time. So that's how it's divided between the sourcing function and measurement functions on the box. And here's some examples of the sourcing capability. So a lot of these, these are from the arbitrary waveform generator. And these are predefined functions that you can just set parameters to, and it will come out on the terminals. So you have your basic DC bias, and you have things like turn on, ramp turn on, staircase, exponential, and a pulse. So if you need any kind of waveform similar to this, it's already predefined for you, and you can just set the parameters. And for example, on the staircase function, you could do that for like an IV sweep. If you want to sweep your component I and B, you can set the staircase turn on function for that type of scenario. And here's a little bit more complex functions that you can set. So here's a trapezoid and a voltage dropout. So for your DC to DC converter, if you want to simulate a voltage dropout on the DC input, you can actually program this dropout from 3.3 to 0, and you can simulate a voltage dropout on a DC to DC converter. And there's also an AC riding on the DC signal that you can simulate. So you can set an AC signal, an offset, a positive DC offset, and simulate a signal similar to this. And on the bottom there are, this is a sequencing function I was talking about. You can sequence the turn on time, and you can also sequence the turn on with the ramp time as well. So on your circuit board, if you have different multiple points of bias, DC bias, you can sequence them to turn on at different times if the board requires that functionality. So, sure.
We have to redefine our own waveform. Can you save the waveform?
Yeah, yes. So you can save the waveform. It will be in a CSV format, Excel format. So let's say you can go into the box and actually define every single point, like point 1, point 2, point 3, point 4. So define everything. It will save into a CSV file, and you can upload it onto your PC, or you can look at it here. So you can save that. You can even save the state of the box. So for example, let's say you have all the measurements set up the way you want, all the waveforms set up the way you want. You can save the state. Then every time you load up the state, everything will come on, like the measurement settings, the sourcing settings, it will come on exactly the same way that you left it. So on the measurement side, we have 3 abilities as well. So we have a meter view. So when we turn this on, you're going to see this is the first view that comes up on the box. So you have the DC voltage, DC current. So these are the readings. That below here, this is the settings that you've put it to. So your settings could very well be different from your readings, and you have that window to show you what they are and how they compare. So that's on the meter view. On the scope view, you can look at the current as it's appearing. So this is a current on a DC fan, like a very basic fan that we've connected our power analyzer to. And you can see that current waveform as it's being outputted into the box. And also the data logger view. So similar to the scope view, the data logger view allows you to capture data, but it allows you to capture data for long periods of time, so for 2 hours, 3 hours, entire day. So it's similar looking to the scope view, but allows you to capture data for a long period of time. So that's 3 different views on the power analyzer. And this is some of the testing that you can actually do with the power analyzer, and we made this list because these are the common types of tests that most users would want to do. And so for example, you can set up the turn on and turn off sequence. So that's what, when we're talking about the delays between channel 1, channel 2, channel 3, and channel 4, that's this kind of sequencing that we're talking about. You can control the DC bias supply, the ramp up and ramp down rates. So we know when you go from 0 volts to 5 volts, it could be this fast, or it could be this fast. So you can alter those rates, slope those rates according to what you want to do. You can also, you can measure voltage, you can burst time, current burst time, and you can also do startup or inrush current. So for example, when you start up a device, there's always some sort of inrush. So it goes up, then comes back down, and it steadies out afterwards. So this box allows you to capture that spike that happens, the inrush that happens on most battery power or DC power devices. And also, in addition to that, you can get peak power requirements. So if you're interested in power as opposed to just voltage and current, some of the modules allow you to look at the power as a whole rather than just voltage and current. And also, we have data logger, and also I can also do DC bias and supply transients as well. So just a common list of different features that you can apply the box for. And this kind of gives you an idea of what, kind of like the value of this box. If we were to kind of create our own standalone system or one box solution, we would have to integrate all these different boxes together. So you have 4 power supplies, you have a scope, you have an ARB, you have a data logger, DMM. So if you didn't have the power analyzer, this is what you have to do. You have to integrate the boxes together. But this power analyzer already integrates everything together for you, so you can save some time on setup for software integration, that type of time. And just a closer look on the front panel, but after the presentation, we'll go ahead and do some features on this box so you can see some actual settings and how it works out and how it shows up on the front panel. And if you want to do remote programming, so if you want to write a Agilant V program, a LabVIEW program, a VB, a Visual Basic program, or C program, C++, you can use these interfaces to help you communicate with the box. So there's USB, there's LAN, there's also GPIB. So these three interfaces allow you to interface with the box. And here's the general specifications with the modules that we have so far. So again, it's a 4-output power analyzer. Total for the entire box, we can do 600 watts in terms of the total power. For current, we can do up to 50 amps now actually. So in terms of, if you're looking for up to 50 amps, this box modules for this box allows you to do that. And these are the accuracies that we're talking about in terms of what it can do. So on the extreme end for our source measure unit modules, we go all the way down to the microamp area. So you can measure really low current down to microamps with an 8 nanoamp error offset. And that's our highest performing module. And for the scope, the bandwidth on the scope is max 200 kilohertz digitizer. So you can measure at 200 kilohertz sampling rate. And for the arbitrary waveform bandwidth, so this is your sine wave, square wave, different cyclical waveforms, we go up to 100 kilohertz for one of our higher end modules. So quite a bit of bandwidth, quite a bit of speed for this one box power supply. And internally, there's a 1 gigabit memory. So if you want to log data into this box directly, there's a 1 gigabit memory inside for you to log data into. And actually, since we're talking about DC to DC converters, I'm going to jump to see if we have actual application. So I have a few slides that kind of describe the application for DC to DC converter and how this power analyzer can actually help you do some of the testing on DC to DC converter. So the problem with DC to DC converter testing is that typically you have a large voltage range and you have a constant power out. So your voltage range could be like 0 to 5 volts for certain power and 0 to 20 volts for certain power. So you have to make sure you get that range. And if you have a very low voltage, typically you have a high current requirement. If you have a high voltage, you have a low current requirement. So this is typically kind of what you're dealing with for DC converters when you're doing this type of testing. So without the power analyzer, to cover this voltage and current combination, typically you have to use a variety of different power supplies because what happens is that one power supply has certain range that doesn't cover the whole operating point of the DC to DC converter, but another power supply has the high range and not the low range, but this has the low range and the high range. So typically you have to use multiple supplies to test DC to DC converters depending on the range you're working with. So the testing requirements really narrows down to a wide range of voltage output, current combinations, in-rush current measurements because we want to test the in-rush on the DC to DC converter, and also efficiency measurements. So you want to know what goes into the DC to DC converter and what comes out of the DC to DC converter for efficiency with measurement purposes. So the N6705 DC power analyzer provides a solution for DC to DC converter testing because it has what we call an auto-ranging capability. So actually, let me use this board to kind of describe auto-ranging. So typically on a power supply, this is a voltage current power supply. Typically, you have this type of characteristic, right? So this is your V max, voltage max, and this is your current max. So this is typically a one-quadrant DC power supply. But what happens is that sometimes you want to, for example, you want a little less voltage, but a little more current. So sometimes you want to work a little bit outside this range, and you might need that for a DC to DC converter because you have a very high voltage range requirement. So if we're just dealing with just this range, then we need more than one power supply in order to meet the requirement. But if you want to cover this range as well as additional ranges, like right here, and also right here, then we're going to need multiple power supplies to get to these points right here, which is outside the range. What we have right now with the power analyzer is we have output characteristic on some modules. It's what we call auto ranging. So the output characteristics on some of the modules look like that. And what this curve is just a constant power curve connecting these peaks together. So what that allows you to do is you can get all of these different ranges in one output. So you don't have to use 2 power supplies. You don't have to use 3 power supplies, 4 power supplies. You can use a single power supply and get all of these. These are the constant power curves, and get all of these ranges that you want to use for the power DC converter. So we have, this is called auto ranging. So this is the auto ranging DC power supply output characteristic. And some of our modules have this output characteristic that you can use to test DC converters. So this is auto ranging we just talked about, and the value obviously is you cover a really wide range of voltage, a really wide range of current, and you can measure basically voltage, current, and also power. Because usually when you're doing converter testing, power is something that you're pretty interested in measuring, because you want to see, power is going to give you the efficiency of what you're putting in and what you're getting out. That's the power efficiency measurement. So you can see all of this data on the front screen. And you can also use the scope to capture inrush current measurements. So this is actually converted. This is an actual scope shot with DC to DC converter. And you can see that at first there's an inrush that happens, then it kind of trickles down. So you can capture this peak, this inrush current peak, using the DC power analyzer. And this might be important to you because you want to see if the peak exceeds a certain threshold that might damage the device, or a threshold that might cause harm to the rest of the circuits. So you can capture this peak, you can see it, you can actually get the data off the scope and look at it from an Excel spreadsheet and CSV file. So is there actually, before we go on, is there any questions on the DC to DC converter testing features and requirements? Okay. So actually, before, I have some other examples, but let me jump to a different slide set to talk about one of our different modules. So we have some new modules that we just came out with for the DC power analyzer. So as I mentioned that this is a modular instrument. It's a 4-channel, and we have over 25 modules to choose from. So what actually powers this box is modules that look like this. So if you open it up, you'll see that there's one module here, one module here, one module here, one module here. So we have over 25 different modules that you can choose from and mix and match between this box. And they do some are basic, so they're basic biases. Some are performance, so it means they go ramp up, ramp down pretty fast. And some are precision, which means they're very accurate. And our newest family of modules is actually what we call our source measure unit modules. So these are, I'll go over each one a little bit in detail in the next couple of slides, but in general, they are 2-quadrant and 4-quadrant modules. So as I explained over here, a typical power supply, you have plus voltage and plus current. But these modules allow you to actually have minus current and minus voltage as well. So they operate outside the first quadrant. And some are optimized for battery rundown, chipset, power management unit, device testing, chipset testing. And some are optimized for other types of testing. So depending on what you're doing, you can choose different modules that go inside this box. So for our first 2 modules, it's 81A and the 82A. This is what we call our 2-quadrant source measure units. So it operates in this first quadrant, which is plus voltage and plus current. but it also operates in the negative current range as well. So, for example, if you look at, so typically, you go to the diagram, you have this power supply. So this is your power supply unit here. You're going to be outputting to a load. So this is typically how it works. But for the SMUs, for these modules, that's only feature number 1. Feature number 2 actually allows you to connect your power supply to some sort of active device. So we call it, let's say, A&D active device. And you can actually pump current back into the power supply. So let's say you want to sync a constant 1 amp. So you go 1 amp, you set 1 amp here, and this device, and this will sync 1 amp and pull 1 amp from this active device. So it allows you to pull current into the power supply as well, as opposed to just sourcing. So that's one of the additional capabilities of these modules. So it's a voltage source, is a current source, and it's also an electronic load. And the electronic load feature is actually in quadrant number 2. So it also has something called glitch-free sourcing and measurement, so which means the output and the measurement systems are independent of each other. So what happens on one does not affect what happens on the other one. And also it's got output transient response, which has a pulse. So for the 81A module specifically, so all of us have like a smartphone, some sort of smartphone device. The 81A module, which is this module, actually allows you to emulate a battery. So if you are using any kind of battery-powered device, this module can behave like a battery and source into your battery-powered device, so you can see what kind of current consumption results from different operations. And it's able, and in addition to that feature, it has programmable output resistance, which is, in actual batteries, there's some sort of series resistance that you always have, and you can program that into this N6781A module. It also has a auxiliary voltage measurement, which is over here. So you can, it's like a voltmeter. You can hook this guy up to anything, and it'll measure the voltage on that, on whatever you're hooking it up to. And these are the ranges that we're looking at for this unit. So most people are interested in the current measurements and how low they can go. So if you're looking at the microamp range measurements, we can do this in nanoseconds of accuracy. So depending on where within this range you want to measure, we provide different accuracies depending on what you're looking at. Probably the one single important feature on this box is this right here. We call it seamless current measurement. So in your device, most likely the current is going to be very dynamic, depending on what it's sourcing, what's being pulled from it. So if you're switching between different ranges here, from a low range to medium range to high range, the seamless current measurement allows the system to automatically select the range that has the most amount of accuracy. And based on that, whatever point it is, it'll actually choose the range that has the highest accuracy and measure using the highest accuracy. So you get this entire sweep, this entire current waveform in one single sweep, and you don't have to do 2 or 3 sweeps to get the different ranges, for that same current waveform. And almost the same with the N6704A. You're going to get you don't get the seamless current measurement, but you do get the multi-quadrant operation, quadrant 1, 2, 3, 4. So this one you can do a negative voltage as well in this N6784A. And here's just a little bit about the different ranges that we're working with. Similar to the previous 2 modules, again we can measure down to the microamp level. And in summary, this is what our new modules can do. They give you the 4-quadrant, 2-quadrant, and single quadrant operation. It behaves like an electronic load if you wanted to, so it can sync from the active source. And you can do actually a measure-only mode. So if you just want to measure and not source and not sync, you can do just measurements, same outputs. So same outputs here. You can do the measurements, you can measure voltage, you can measure current. So this is all the features that are packed into that I guess it was 3 modules that we just kind of went over. So actually, with that, I can turn on the box and give you guys a quick demo. see if you guys. I actually don't have my demo kit, so I'll just show you some features that I can show over the box. Can everybody see it? It should be positioned differently. I feel like I should go in here. No, I can just do it right here.
Yeah.
It's okay. Everybody can see it. All right. So first, so here's a shortcut. If you ever want to see what modules you have on here, which is the first thing that most people want to do, you click on two buttons: Setting, Properties, and you can see exactly which modules that you guys have on here. So it looks like you guys have the basic modules on here. So setting and properties allow you to see which modules. So on the different views, this is the most basic view for channel. You click here once, and it zooms in on each one of the channels, and you can cycle for each one. So yeah, pretty easy to set up, pretty easy to kind of cycle through the channels. So let's say we want to program something really basic, so 5 volts, 1 amp. So what we can do is just you can actually do it from this view, the 4-channel view, or you can zoom in to one of them. So we'll select channel 1. We'll program 5 volts. 5 volts. We'll program 1 amp. Then we'll enable the output. So just like that, you can enable the output. And you'll see the readings right off the front panel as well. You can see 5 volts. Right now, 0 amps is coming out, and that's because nothing is connected. So let's say you want to do something a little bit different. So let's say you want to program a basic waveform. So we'll do a sine wave. You press the arbitrary waveform button, go into properties, and here you can see the different waveforms that you can select on this box. So there are going to be a bunch of predefined functions and also a custom function. So we'll select the sine wave. And when you select the sine wave, the waveform will show up, and you can look at the different parameters. So we'll do a 2 volt, and we'll do 100. Let's do 100 hertz. So you can select the voltage level, the amplitude, and also the different frequencies. Maximum frequency is so this module is going to be about, I want to say 500 to 1 kilohertz is the maximum frequency for this basic module. So you select continuous, so which means that this waveform is going to repeat over and over again continuously. If you don't select continuous, what happens is that it goes once and it stops. You get DC again right after that. So what we can do is, so we want to see the waveform, right? So we select the waveform, we did the settings, so now we want to see it. So we go to the scope view, we select voltage on channel 1, then we run the waveform. See this run stop button? We run the waveform, and you see the waveform on the screen. So here's an interesting trick. So you guys want to use auto range? Usually that's easier, right? If you auto range on a scope measurement. So you press this button again, and this is auto ranging. So this is your trigger knob, but if you press it once more, it auto ranges that signal for you, so you can kind of see it a little bit better. So let's say you want to, so now you've captured the waveform, and you want to take a better look at it. So we can stop it. So we can stop the scope. So this waveform is frozen, and this is something that is sometimes not intuitive for me. You press the scope view one more time, and you get these markers that come up. Can you guys see the markers? You see the red markers that come up. So it's exactly like a scope. You get the vertical markers, and you can kind of block off whatever block that you want to look at. It'll give you min, max, average, frequency, that type of insight. So you can get the markers that come up. So once you're at this point, let's say you want to get this picture onto a report, you can actually capture. So you can go to File, and there's a screen capture. So you can capture that picture, put it on your report. What you can also do is, once you're at File, you can use the export function. So the export function, what it does is that it exports that data that creates that waveform into a number format. So you get a CSV file, exact raw data that creates that waveform. And with that, you can export it to your PC, look at it on your Excel program. So different functionalities. And same thing with so we just saw the scope view. This is a scope view. For the data logger, it's the same thing. We can set the amount of time that we want to data log, and we can log this sine wave continuously for hours and even for a day. So another interesting feature that you guys might find useful. So you see we have these different waveforms that you can select. So for example, if you want to, so I'll draw on the board. For example, sometimes you want some really complex waveforms. So you're going to want like a sine wave plus this. So you want a waveform that's created by different things. So sometimes you're going to want that. And we have a feature that allows you to create that. So if you look here, you're going to see a sequence function. You click on it. So let me stop the R first. R properties, sequence. So you're going to see this list right here. So in each one of the slots on the list, you can select the different waveforms. So you see, if I get the drop-down menu, I can select sine wave, I can select trapezoid, ramp, and you can configure this list to whatever you like. So you can have 4 or 5 different waveforms cascaded with each other, and it will come out the output exactly the way you programmed it. So that's one feature, and if you want to actually create your own list, you're going to see that there's a user-defined option as well. For the user-defined option, what you do is you create every single point exactly as you want it on your waveform. And using that, you can create a custom waveform that's totally different from anything that you see that's on the box. So let me go to one of the, so that's sort of the arbitrary waveform feature on the box. And the one last thing I want to show is, see if I can get the sequencing feature out to show. Source settings. All right, so using the output sequencing feature, this is the menu that you would go to if you want to define what the delays for the different turn-ons. So as we saw in the previous slide, oh, not on this slide, on this slide, but you can have different ramp-up times for different channels. So this can come on 1 second after channel 1. So if you want channel 2 to come on 1 second after channel 1, we just put a 1 second delay here. And what you program in is exactly what you're going to see. So it'll show you in graphically right here how it turns on. So you can see exactly how it turns on and whether that's the way you want it to turn on.
What's the minimum time step for it?
Oh, the minimum. That's a good question. Let's see. I'll see how small I can put this. So let's see. 0.001. So that's 1 millisecond. So we'll see if that. So it's not 1 millisecond. So you can go lower than that. Let's see if we can go 1 microsecond. Yeah. So it's going to be probably, I want to say like probably 10 or 100 microseconds is going to be the minimum because it doesn't let me take that point. Unless it's taking it, but I don't know, but most likely it hasn't. So yeah, it's probably going to be around maybe 100 microsecond to 1 millisecond resolution is what you're going to get based on that. Would you guys, is this feature something that you can use for your testing, sequencing, output sequencing, or delay feature on your circuit board? Do you need multiple biases? Or most likely, this is probably more useful. The scope function is probably a little bit more useful for your testing needs. But okay, so yeah, so that's basically the overview for this box. Is there any specific questions or features that you guys want to talk about?
혹시 테스트 하시면서 더 조금 해보신 분이나 아니면 좀 궁금하신 조금 더 좀 설명을 해줬으면 하는 분 있으신 분 말씀해주세요.
What's the minimum amplitude that sine?
Minimum amplitude. Oh, okay. So minimum amplitude. So it depends on the modules. Because typically, actually, most people ask what is the maximum maximum amplitude, and based on the rating of the module. So if I go to, so I'll explain. So maximum amplitude, how you would look at it is you look at the voltage rating, and that gives you your maximum amplitude. So for minimum amplitude, you can actually program it to very low levels. Like I've done it in millivolts, like let's say like 10 millivolts or 20 millivolts. You can actually do that for this module. So what are you looking specifically? Do you know what you want?
To test and match, I need sine pulse power supplies with this biasing. So if I can use that, I need 30 kilohertz to 100 millivolt.
Oh, okay. So you so you want like let's say you were using a sine wave. So you want a sine wave and you want this to be 130 millivolts. Is that it?
100 millivolt and 30 kilohertz.
30 kilohertz. Okay, 30 kilohertz and so for 30 kilohertz, most likely the module, if you have the basic modules in there, most likely that's not going to reach 30 kilohertz. These are probably limited at about maybe 500 or 1 kilohertz, most likely. But the amplitude is definitely possible for this amplitude. So this should be no problem for the amplitude. But yeah, 30 kilohertz is starting to reach a little bit above the requirement or capability of the module, of this module.
Does it have any FFT calculation?
FFT?
FFT?
Oh, not built into the box, unfortunately. No FFT built into the box calculations.
Or any differentiation operation? Suppose differentiation operation or integration operation of a signal.
Yeah, so actually, on this box, not on this box, but if you want to perform like mathematical operations,
Yeah.
we have a software that actually comes on a PC that works directly with this box, and you can actually perform the mathematical operations on the software. Yeah, so not directly on the box, but on the software. And I'm not sure you guys had a chance to test it yet, but it's actually the software is let me get a 145A5A. So this is if you Google that, that's the software that comes up, and there's a 30-day free trial that you can use, and the mathematical operations are actually available on the software. Any other questions?
뭐 다른 뭐 꼭 이것만 아니더라도 뭐 쓰시면서 이런 기능이 있었으면 좋겠다는 것도 괜찮거든요. 뭐 이거 쓸 때 요거로 이 기능이 있으면 더 편하게 쓸 수 있겠다 이런 거 쓰시고.
Or actually, if you want to talk about your specific tests, do you have any challenges or anything that you find difficult? I can kind of talk about how this box can solve those problems as well.
지금 아까 뭐 설명드렸지만 이게 25개 모듈이 있어요. 그래서 여기 안에 이제 4개 슬롯이 있어서 거기서 자유롭게 선택을 하실 수 있거든요. 지금도 아까 조금 전에 나온 그 새로 나온 SMU 모듈도 나왔듯이 계속 어떻게 보면 이제 그 쓰시는 용도에 따라서 선택을 하실 수 있게끔 바뀌거든요. 그래서 지금은 없더라도 뭐 이런 문제가 있다라고 뭐 말씀해 주시면 또 추가적으로 추가를 거기에 기능을 넣을 수도 있는 거니까 좀 이게 기존의 기본적인 파워 서플라이와는 약간 다른 장비입니다. 사실은 보시기에는 기능적으로도 이제 다른 기능이 들어있지 않습니까? 별도의 장비가 있어야 되는 스코프라든가 데이터 로그 이런 기능들이 같이 있기 때문에 상당히 좀 어떻게 보면 간단한 장비는 아니고요. 그렇다고 뭐 쓰시기 어려운 장비는 아니에요. 근데 굉장히 어떻게 보면 유용한 면들이 많이 있거든요. 그래서 뭐 어떤 거라도 뭐 혹시 테스트하시면서 필요한 거 있으시면 말씀해 주시면 되고.
the phase, the sine wave, you can actually set a, let's see, some arbitrary, so let's go to the sine wave, arbitrary sine wave. So you want to start it at a certain phase, maybe, or put it in a certain. So what happens? So let's say you have two sine waves, one in channel 1, one in channel 2.
But I want to
Same
differential.
Oh, differential.
Yeah, sine wave. Channel 1 with different and channel 2.
different phase.
Oh, okay, different phase. Yeah. Yeah, it's time delay. Yeah, so you can time. So if you know the period, then you know what half the period is, quarter of the period is. Then you can program that phase difference in the time delay. Then it will sync the phase, either sync it, invert it, or just set it off by different timing.
Those sense terminals for measuring.
Yeah, so sense terminal. So I can explain that as well. So, for example, this is the power supply. This is the power supply. You have the plus, you have the minus, and this is going to, let's say, a resistor. So what happens is that these leads from here to here to here to here. This is a certain resistance, so we call it resistance. We call this. So you have this is resistance right here. So if you program 5 volts over here, and let's say there's some sort of resistance here, what you get across here is going to be 5 volts minus some sort of number, because there's a drop here and drop here, right? So with the 4-wire sensing, which is on the box, you can sense right here. You can sense around the resistance. So this will give you, instead of 5 volts you're putting out, it'll give you 5 volts plus whatever drop this is. So what you get over here is exactly going to be 5 volts, right at the device under test. So this senses around this drop that you see in the circuit. So if you want very accurate, very exact voltage regulation, you use the 4-wire sensing to sense around the leads. Because every wire, every wire like this, there's some sort of parasitic or some sort of resistance on these wires, and it will cause a voltage drop across your circuit. So it's for a measurement regulation type of requirement. So did you want to know how to use this as well? This box. So currently, are you using this box right now, or just got it and not using it? You have used it? Haven't used it. Okay. So you want to know how? So this is like ELO, right? So you want to sync. You want to use this to sync, right? To sync power. So okay. So most likely you're going to have some sort of source, and that's going to be connected to the N. So this is your device under test. It's going to be a source, and you're going to connect this to the N2300 electronic load. So basically, it's very simple operation. You have 2 choices really. You have choice number 1. You have a constant current. Choice, it's actually on the other side. On this guy, on the ELO, you have 2 choices. You have constant current or constant voltage. So there are really 2 choices that you have on the ELO. If you choose constant current, let's say you choose this one, and you select it to be 1 amp for constant current setting, this will pull 1 amp from your source, and its entire job is to regulate this 1 amp. So be 1 amp only, not 2 amps, not 3 amps, just 1 amp going through the circuit. Let's say you chose constant voltage. So let's say you choose constant voltage and you do 5 volts. So what happens is that this will regulate 5 volts across this terminal. So it will regulate 5 volts, and its entire job is going to make sure 5 volts appear. Doesn't matter what current this is, only 5 volts. So it's going to sync whatever you connect to it, and you have a choice between whether you want to regulate voltage or you want to regulate current going through that test. And for example, too, so another feature. Let's say you want to do constant current, and you want to do something different. Like you want to pull 1 amp, then you want to pull 5 amps, then you want to pull 10 amps. You can actually make a table on the electronic load. So you can make a table like this, and you can put the time that you want this to sync 1 amp, this time you want to sync for 5 amps, the time you want to sync for 10 amps. And it will, once we load it up and start it, it will run through this table, kind of like an arbitrary waveform, but for loading instead of sourcing. And you can sort of program the timing you want for each one of these as well. So it's a very simple box for just loading. In fact, you can connect this to this box, and it will sync the current from this box. For the ELO, unfortunately, I do not have any presentation material. But if you have wires, I can connect it to it.
그 power analyzer, it's easy to use. For E-load, I have tried to use this E-load. I couldn't do it.
Oh, so
Interface.
oh, you put in just a basic syncing, basic feature. You can program this.
I want you to control the resistance. I am free.
The resistance? Okay. You want to control the resistance of the ELO. Okay. So yeah, so there's a constant current, constant voltage, and also constant resistance mode. Most people use constant current to regulate because constant resistance is in some ways just constant current because you know what current you want. Like basically, you know what current you want to sync, right? You know what current. Actually, if you know the resistance, then you know the current that you want to sync, and you can program onto it directly. And actually, do you guys have a pair of wires? I can show you. You have a pair of wires. Unfortunately, I don't have a presentation for the ELOs.
Do you have the values for this ELO? You have values? No values? No.
So you guys short off this chassis ground. Is there a reason for that, or you don't like the floating outputs? Notice you short everything to chassis ground over here. Oh no, I just want to see. I wonder how come why you connect everything to chassis ground.
We usually use power supply at the same time. One DUT.
Oh, and the reference on DUT is chassis ground. Oh, okay. Yeah, I understand.
Same modules are four modules are the same.
Yeah, they're 43B.
Are they put in parallel or series?
No, I think what his reference on his board is chassis.
You just said
ground.
like usually at the same time. What does it mean?
So do you use a parallel configuration or individual configuration?
저 위에 슈트 시키면서
The neutral terminal are internally connected.
Yeah,
No. I forgot about this wire. The 4 channel has 4 neutral terminal, and these 4 neutral terminal are internally connected.
Okay, they're internally referenced.
But I thought maybe due to some resistance, we put some front end wire so that the ground resistance can be minimum.
Okay, you limit the floating, you limit how much it floats, basically. What is, for your device, is the reference chassis ground for your device in your test? Because, or is it reference?
Yeah.
It's chassis.
Suppose in our device we need two source, but if we get from the two separate node, then the ground is connected through the internal.
Oh, okay.
Right, but if I put some front end connection, then the resistance due to this long path can be minimized.
Okay, yeah, you want to, what is it called, like ground current? You want to minimize,
Yeah.
So the device will also connected to the ground terminal?
Yeah, so what happens is that internally, their reference is all connected internally. So if they did not short this all together, the reference will be made inside their board, which they don't want. They want the reference to tie.
So they want to
outside.
cut the ground loop.
Yeah, ground loop. Yeah, that's actually the word I was thinking. The ground loop. They want to cut the ground loop.
So the device also connected to that ground. Otherwise, you're gonna cut. It's still
It doesn't have to connect it to this ground. It's not connected.
I mean, the device has to connect it back to.
Yeah.
Okay.
Yeah, ground loop. That's what I was looking for. That's what I was looking for, ground current. But yeah, I can. Once he comes back with the leads, I can show you how to quickly program the load. You have 6 channels. Are you using all six channels? Every one? 1, 2, 3, 4, 5, 6.
I can choose this 이거는
8 channel. Yeah, 6. Yeah, 6. Yeah, well, now it's 6 channels. Sorry? Only this one? Okay. Yeah. And so you program constant resistance that you want to be able to. You got wire psyche?
오늘 일단 좀 보여드릴 수 있는 내용 보여드리고요. 그다음에 저희가 이제 엔지니어가 로컬에 또 있어요. 그래서 일단 오늘 약간 미진한 부분은 다시 한번 저희가 연락을 드려서 도움을 드릴 수 있도록 그렇게 진행을 할게요. 어차피 제가 보기에는 로브는 아마 거의 지금 잘 많이 써보시진 않은 상황이라 구매하실 때나 이럴 때는 바로 말씀을 안 하실 것 같은데
이 나중에 좀 마련해 주신다고 해가지고 이거는 그냥 이렇게 쉽더라고요. 이거는 뭐가 뭔지 하나도 모르겠어가지고 자기 기회가 있을 때까지 쓰려고 하시면 만약에 오늘 생각도 잘 안 돼도 모르면 나중에 저희가 연락을 해서 답변을 얻는 식으로 된다는가요? 아니면 이렇게
연락을 주시면 이쪽에 영업 담당하시는 분께서 어떤 식으로 도와드릴 수 있는 부분을 말씀을 드릴 거예요. 그래서 일단 오늘은 설명 먼저 들으시고요. 그 다음에 저희가 추가적으로 저희가 드릴 수 있는 부분을 좀 말씀을 해주시면 돼요.
So actually, before we get the wires, I can show you very quickly. So first, so to circulate between the channel 1, channel 2, channel 3, channel 4, you just press the channel button, and you can put some different channels. And that's why we don't turn our instrument on. Okay, so you can choose, so this is a function, you can choose different functions here. So for example, you choose function, and I can choose current, and I can program whatever current I want to say. Or I can choose function, resistance, program resistance, function, voltage, we can do voltage. So most likely, so what happens is usually this. So if you have a power supply, let's say this is your power supply, you connect it to the E-load. So you have to really, you have to, whatever's the setting that's here cannot be the setting that's here. So for example, this is constant voltage, power supply. E-load has to be constant current. And if the power supply is constant current, E-load has to be constant voltage. So it has to be different. Like you cannot have, for example, this cannot be CV and this is CV at the same time. Like you can't have this. Yeah, it's a conflict. Whatever's here has to be different from whatever's there. So, if you look back here, one thing is very important. You see this button over here? This is remote sensing. This is local sensing. So make sure if you're not using this, set it to local sensing. So make sure it's not this, but it's push in. Okay. So right now the positive is going to the positive, negative is going to the negative. Okay, so this is what we're going to do. So we'll program 5 volts, and we'll program 5 volts and 4 amps, right? So, let's see, function curve there. Okay, so input is off. So what do you think is going to happen when I turn this on? It's going to be, should be 0 amps, right? This is off, so it should be 0 amps. So 5 volts, 0 amps. But so let me program my settings. So I have constant current program, right? So I want to sync 1 amp. So I press 1, press enter. So now you can see that it's opening 5 volts and it's sourcing 1 amp. And that's because we program 1 amp over here over the front. So
I program resistance
I'm sorry, waveform. You're using this? Yeah, so you can program, so not a waveform. You can program control the resistance. So we can do that too.
I wanna measure the load trend response. Load trend response. If we change the load, if we change the load resistance, the output of the supply can change suddenly or drop or.
Oh, if you change the loading, this can change. You're talking about this can change this setting as well.
Not this one. This one.
So you want to change the resistance?
Change the resistance manually.
dynamically?
Over time.
Over time. Yeah, so you can change the resistance over time as well. We can't do it directly. We cannot do it on a touch panel, but you have to connect this to a PC, and you can set up the list. So the list I was talking about back there. So you know what? I talked about this function. So you can do the same thing. So you have CR mode, so constant resistance mode. You can make the same list here. So you can make 5 ohms, 6 ohms, 10 ohms. You can make the list. Then this is you can choose like 1 second, 3 second, 5 second. So you can set this table up, load it onto the PC.
Is there a program?
No, you don't need program. You can download Agilant IO library. So it's free software, free program, and it's like a command. So the command is going to be like list point. Then you start going 1, 5, 6. The resistance that you want. So this is just one probably like 3 or 4 commands to set up this. But you punch in the commands and so it's called. Let me see if I can show you on mine. This software is free. It's a connectivity software. It works on all your Windows PC. So you just open this software up, and you have like a GPIB cable, USB GPIB cable. You can find an instrument. The instrument will show up over there, and then you can open up a window. You can send commands like that over to the box. You can set that on the table if you want to, resistance or current, different tables. So, does this answer your question? Any other questions? Any other questions? If not, I think
그러면 질문하실 내용 다 끝나신 건가요? 일단 혹시 오늘 간단하게 설명 들으신 걸로 한번 해보시고요. 그다음에 여기 지금 작성하시는데 연락처를 좀 적어주시겠습니까? 그러면 저희한테 직접 연락을 담당하시는 분 혹시 아십니까? 영업 담당하시는 분? 예, 알고 계시면은 영업 담당하시는 분한테 연락을 주시면은 어떻게든 도움을 드릴 수 있는 방법을 찾아가지고 도와드릴 거고, 사실 이걸 구매하실 때 저희 교수님께 몇 번을 여쭤봤었다고 그러더라고요. 지금 방금 보니까 어떤 장비 사용하시는데 문제점이 있으신지. 근데 사실 교수님께서 직접 쓰시질 않기 때문에 이런 말씀을 안 해주신 것 같아요. 근데 어쨌든 뭐 지금 쓰시게 되면 어차피 이제 말씀을 해주실 거니까 저희 그 영업사업 통해서 영업 담당하시는 분 통해서 말씀을 해주시면 저희가 도와드릴 수 있으니까 오늘 또 덕분에 또 찾아뵙게 되니까 또 들을 수 있어서 좋은 것 같고요. 혹시 다른 내용 혹시 더 추가로 뭐 말씀하실 부분 있으십니까? 없으신가요? 어려운 시간 내주셔서 대단히 감사드리고요. Thank you for recording. Do you plan to upload the YouTube? 네, 감사합니다. 예, 오늘 이 정도로 마치겠습니다. 예, 고맙습니다.